Hello everyone. So today I'd like to go and write up a example for arguments in Little A. So from n we will import arg count and arg at. Then we'll have main. Of course, what main will do is it will say let arg c equal arg count, and then we will print args argc starting at 0 and argc even. And then we will have here print args, and this we will call the index, which will be an int, and the arg. In fact, we won't need to call it multiple times. We can just say print args starting at 0, right? So if the index is greater than or equal to arg count, we can then return. In any other case, we'll need to write out, which will take a syscall, and we need to also grab the syscall numbers to know which syscall we need to grab. So from I just need to look back on one of my examples for this. So that would be hello world named. Import right now. And we'll need to grab Sterling as well. So that would be syscall right num. And then if I look at hello world named, that should tell me what I need to input. I need to input the file descriptor we're writing to. So in this case, 1. The text that I'm writing at, which would be arg at the index, and the length of the arg at the index. Well, let's say let arg equal arg at index. And that means this can be arg, and that means this can be Sterling of arg. And then after this, I will need to output a new line. And this can just be 1. And then we will print it, and then we will recurse with index plus 1. Okay, so let's see if that works currently. Just checking that the most recent version is built. And then we can say this, and we will run args through it. Debug dumping, of course. Okay, there is no such file or directory, because the env module doesn't exist. In fact, it's effectively going to be an inbuilt module. So, if we go to the parser, we need to tell it that env is not a valid module. So, in fact, we should not. Let's see, in main, we should make sure that here, not double load files. Are sudo only containing intrinsics. So if file name exactly equals env, we can also just continue. Now if we do that again, interesting that it ends there at line 55. Source main line 55. What module did we fail to parse exactly? We failed to parse env. That's interesting. Maybe because when we... yes. When we load the module, we have here. So what we probably will want to say is that this actually needs to be here. And instead of being module, we can just say iter.first. That's interesting. So there's two places we check for whether a certain module should be loaded. That's a later issue. We get further. Okay. From modules, sorted size should equal import size. Well, I know why that fails, because we had an extra module in here that did not. And that was in file program CPP. And 144. Yes. Okay. So when we sort the modules, that's interesting. We sort the modules. Why is the sorted size different from the module size? Well, the sorted size is the topological sort over the dependencies. And the dependencies would be the list of modules that we have. Let's see. So if we add some debugging, so we're at 3 modules from the input of 2. Right, because the dependencies of because what's happening here is that this sort runs over env as well. We would have to be able to mark a module as pseudo. Make generic for more pseudo modules. Sorted 3 modules from the input of 2. Still. Oh, that messed up. Wait, it's not here. It's in here. If the dependency is named this, we should not do anything. Right. Sorted 2 from 2. There we go. File env does not export arg count. And that is in the type checker at line 384. Here I expected. So program globals we have to look up. Program globals is passed in as a global map. So now we have to go to our program and tell it that we need to load in globals. Right? So program globals, we'll have to add that there is a module named env that has a args count, and that has a type of I forget how to make a function type. So we open up the type. Function type takes a return type. Well, I know the return type here is going to be an integer. So that makes this int 32. And nothing else. It doesn't take any inputs. And then we can also add arg_at. Was it args_at or arg_at? Args. It was arg_at. Arg_count. Over arg_count is going to be a function. As we can see here. And now this function, arg_at, will return a stir, but we'll take in AST, primitive type, integer. And now we will see what is the error here. We call ninja. Okay. No matching function to make shared. Doesn't work over the template values. Okay. So this does not work, but what I can say, let's try this, is to wrap the whole thing in curlies. No function called correct for it. Well, I can just then use function type here. And that should work. And then if I were to run this, return should have an expression in a non-void function. I think my example is wrong. Well, print args is a void function though. Unless I'm in a wrong return. I will have to see what function we're in, which is in the type checker. Return. Oh, let's see. Maybe if I look up the word non-void. There we are. Return must have a non-void function. What is our current function, though? Do we know a way to get it? Or are we not able to do so? Let's see. When we visit a function, okay. When we visit a function, we get its return type, func name. Bind function type to the function name. We have no way to know what function we're in. We probably should add that. Let's see. If I were to go to the type checker, return type. We can also have a pointer called the current function name, which will initialize to null, and we will say that this is const. And so here, when we bind the current return type, we will also bind the current function name, which would say that the current function name is equivalent to the address of func name. And that should work because the reference of func name goes into that, which returns a string reference. Probably mark that that only works on references. And then we need to jump back to there. Let's see, does this work? Okay. So when I look for a return statement, a non-void function to reference the current function name found in function. And thence we can make, let's see what happens. Okay, no problem. If we debug, print args is a non-void function. Strange. Why did it decide that print args was a non-void function? Let's see, what if I just try and tell it explicitly that it returns unit? Could not find arg count in the module. And now we're in code generation. Let's see. I'll have to debug that later. Why is type checking failing there? So now we get to go to code generation. So for code generation, we need to do an intrinsic. So to add an intrinsic, we would need to, we have our list of intrinsics here. This would be arg count as a call data, right? Then here, we would ask for arg count, which takes in an address to codegen arg count. Then we can, where is syscall? There is syscall. So before syscall, we're going to have a much simpler function. In fact, I can also do arg at that. I'll insert this unused mark. So here what we need to do is we need to be able to get our args out. Now, so here we have argc, which we will need to read from. In fact, argc is not going to be great because we should actually only reserve 4 for space. And then this, we can paste that down there and down there. And this we should only do to the power of 2. Move argc. Actually, I think that should be fine. P. Start that hunk and quit everything else. So here, when we get the call data, we need to have an externally initialized global. That's what we need. So to get the externally initialized global, create a new LOVM global variable, I think. And this is the part where I need to open up a web browser. I will bring it over to this screen so that we can see it together. We need to find an LOVM type. In fact, we probably will want to find an LOVM global variable. So a global variable, it needs a type. And for the type of this global variable, I will say it is an LOVM. Let's just say that it is, the variable itself will have to be a 64-bit integer. Let's see. Then here to get the context, we can just pass in I forget how I named it. Is it LOVM? This arrow context. It is just context. Okay. Now we also need is it a constant? In this case, we'll assume that it's a constant because we shouldn't be writing to it. Linkage type. Well, that can be a linkage types. Where is linkage types found? Linkage types is global value. We want this to be a this would probably be a public linkage or external. Probably an external linkage. Then we will need an initializer and a name. Well, I'll worry about those later. Let's call this raw arg count. Introduce the type a bit better, and it's an unused variable, of course. We will say that the raw arg count should set its name to, as we saw there, argc, if I remember correctly. Yes, argc. Okay. And then we should tell it that it's externally initialized. Set externally initialized? Well, explicitly true. I don't want to duplicate this, so I probably want to say something like find an alive value, argc. If raw arg count is null, then we need to do this. LOVM value, right? Let's call this the new raw arg count. Which will then put new at the front here, so that we know that this is the type. And then we will say that we can forget, how did I... It is with... Where is the adding a value into the aliveness? I forget. Maybe the let deck will tell me. Active values back in place. We probably need to write that as better. Let's try the consts. Const decal. Active values in place. Right. Dot back. In fact, we should probably place it at the front. So let's try front dot in place. And we can say here that we want in place argc and the new arg count. New raw arg count. And then here, we can just say that the raw arg count should equal the new raw arg count. Now that that's done, all we need to do is we need to say store value, store the result of, if I remember correctly, we need to do an LOVM load on this, which would be the IR builder, create a load. As you notice, there are about 6 different overloads, so I will, my apologies while I go and dig up the LOVM IR builder. On my second screen. Create load. The type that we will want for this is the 64 integer type. In fact, I will yank this, paste it up here, since we will want to get this twice. We want to say this is the LLVM I64 type. And then this can be rewritten as the LLVM I64 type. And then here, the load will be for this type. In fact, we will probably need to I64 type. And then we will also have the value, which is the raw arg count that we were loading from. And this will return a load instruction, which we will take as the long argc. And now I need to know how to truncate, create a trunk. And then we will store the result of an IR builder arrow truncate trunk, and the value that we're taking is the long argc that we just loaded, and the type that we're truncating to is find type. Find type. Well, that we will need to send in. Find type takes the AST type, and here we want the AST type to be AST the primitive type I32. And that should work for our count. While we're at it, we might as well try and write up arg at. We'll need to find the value args, or more accurately, argv. Now the type here for argv is not going to be the same type as the as our count. In fact, I probably will want to add this here just to make sure that I'm correct. So arg at, this is cogen arg at. There. And then arg at. So here, instead of the I64 type, we want a pointer-to-pointer of string, effectively. So we want to get the int8 pointer, then get the pointer 2. But let's just get this. So this is the, we'll call it the string type, which instead of being the int64 will be the int8 putter type. And if this is not the case, we will now need to have a global variable, which will use LOVM type. In fact, it will use the LOVM stir type, get pointer 2, externally initialized. We will set the name to argv. We'll say that it's externally initialized. We will set it to argv as well. Then we create a load of our stir type. In fact, we can't create a load. We instead need to get the one item of function data we have and evaluate that. So let's call it func call data. Let's call it data. We will now need to assert data.size, args count exactly equal to 1, and that data.arg of, then we will have to value, let's call it index, is the same thing as, it will be the value that we get from evaluating data.arg at 0 in the this context. And here, instead of that, we will now need to do I believe we can create a gep. I think that's the term. Get element pointer. Now, gep So the first thing we need for the gep is the type. Well, I want it to be the LOVM string type. The value that we are loading from, which is should not be called arg count. It should be called arg vector. And so we are loading from the raw arg vector, and the index that we were passing in is the index. Now if I make this, should be fine. And then if I were to debug build this, could not find arg count in exports of the module, in the exports of env. Ah, right. Let's go down to that line then. So cogen line 653. So here, in a program globals lookup, program globals, where's that declared? That is something we pass in. Takes a bunch of LOVM global objects. But I don't want program to know about LOVM objects. So for now, what I will do, is I will make a special exemption. I will say that if the source module is env, we can continue. We continue on. And of course, cognitive complexity takes hold. Ninja. Could not find value argc. That is interesting that it could not find value argc. Cannot find value argc. So we cannot find that value. But if we were to come down to arg_at, we would place it at the front of the active values. And I realize it always pop backwards. Unless we are not walking through the scopes correctly. The other options, we could store this in program globals. But that would technically allow access, well, that would allow failure earlier on, so. Let's strange. Wait, I know why. It doesn't, the error here. Aha. There's the problem. The print error fails, and then we return null pointer. We may need something to say that we should fail. Okay, let's try bool should error is unused. Well, if we should error, do this. But the definition is now wrong. So if I jump to this definition, I go to find a live value, and I can say bool should error, which will initially be true. In most cases, we should error. Except in arg_at, where we should not error, so we should say false. And in find a live value, where we should also not error, false. Ah, even a different error. The get failed. Because it is saying that when you try and cast the pointer type to its scalar, it should be either opaque or some pointy type matching the pointee type. Okay. Let's GDB this. We will run with examples args.little. Backtrace this. Okay. Backtrace is at arg_at. I sort of expected that. So, CodeGen 2.9. So here the get fails. So what if try to print out an LLVM style? So deref of the LLVM stir type load from deref of the raw arg vector. See what happens if this occurs. So we have that, which we should try and load from here. Which fails because the point E should not. Okay, time to read some more documentation. So